and has over 13 years of experience in design and development of SaaS platform for capital markets, platform applications and services for the IoT, connected fleets and enterprise contract lifecycle management suite. So I welcome you, Gaurav. So you can start the session. Over to Gaurav. Thank you.
Thanks, madam. So, am I audible now?
Yes, sir, you're audible.
Okay, good. So, we'll start with the session. So, thanks for the quick introduction, ma'am. So, I think one thing that you missed out is that I was also an ITK student from 2004 to 2007. Yeah, I did my master's, my MCA there. Yeah, and after that, I joined Day4 through campus placement, and then after that, I joined SAP Research India. Then briefly, I moved to Genpact, and now I have been with SAP Labs for almost 8 years continuously. Yeah. So that's a brief intro about myself. So today I would be talking about web application security in general. So this would be more of a conceptual talk based on whatever, say, my understanding is about web application security. So almost my entire career I have spent building distributed applications, right? So ma'am gave you few examples of about that. We built few applications for IoT, few for financial domain, few for hedge fund, and recently I have moved to enterprise contract lifecycle management. Okay, so I have done throughout cloud native distributed application development, and this talk is more about what I have learned throughout. Okay, so I'll keep it conceptual. We'll talk about, so the idea is more to give you an understanding of what the things are, right? And then towards the end, we'll have a lot of references where you can go into more details about each and every concept that I talk about. Yeah. So with this note, we'll get started. Yeah. So talking about the agenda, just to tell you the importance of what we are going to talk in next 1.5 hour, right? So I have collated few security breaches that has happened in last 2 months. Okay, we'll just quickly go through them so that we understand why these things are important. Yeah. Then we will set a conceptual model of basic security principles that we can use whenever we are designing a new system or say a part of a system, or these can be applied even when you are introducing a small feature as well, right? Then there is another way of looking at the whole security concept, that is the risk-based approach, right? Because as Indians, especially, like, we are very risk averse, right? We don't want to take too many risks, and maybe that's the other idea of thinking about the security implications. Yeah. Then I have just kept one slide for reference on some common web application attacks, right? And there are much more which are not captured in this slide. We'll quickly go through that as well. Yeah. Then I want to touch upon the OWASP top 10 standards. Yeah. What they are and how they have evolved over time, and what essentially are the preventions for these attacks. Yeah. And then we will talk about HTTP security headers, mostly the response headers that are very much relevant for your client server type of systems or your API platforms, right? So nowadays everyone is building SaaS platforms, right? So these headers and setting them properly is very important. Yeah. And then we'll touch upon how to incorporate all of these above things into your secure development and operations cycle. Yeah. So it's very important that whatever we learn has to be applied as well, right? It doesn't sticks to the books and our notes, right? It has to be put to some practical use as well. Yeah. So I'm sure this talk would be very relevant for most of you, as you are all PG or UG students, right? Going forward, you would be joining some companies, or you will maybe go for higher studies into technical domain, or you would probably continue with your research work and all, right? And if this happens to be your area of research, then probably this would be a good foundation to help you through. Yeah. So Looking at the top or maybe few of the security breaches that has happened in the last 3 months, right? So uh, these are very few security breaches that I have taken. So please don't read through the entire text. I have just kept it as a reference so that you can refer it later on. But just refer the names and the text highlighted in yellow. Okay. So starting with say ancestry, Clubillion, and who doesn't know Twitter or Cognizant here, right? So just read through the text in yellow. So the ancestry attack was more due to unsecured server, right? Because of which a lot of sensitive data of up to 60,000 customers was revealed, right? Then maybe we talk about Twitter, right? Where the attack was exposed to the data through the browser caches, right? The data was left in the browser cache, and then that could be used in the sessions or by the applications later on. Yeah. Cognizant attack was more of a ransomware attack, right? Then more important is the U.S. Marshals attack, which was the attack where a few millions of inmates and inmates' data was revealed, and this was due to a server vulnerability, right? Then the last one is the GoDaddy attack, right, where unauthorized third party was granted access to log in into the system, right, and there the username and passwords of 24,000 users were stolen, right, and much more were impacted. So if you see, and at the first glance, you will just try to make out like why it is so difficult to have a secure server, right? Having an unauthorized third-party access in your system, or having a leaked database, right? I mean, to our understanding, these things look very trivial, right? But imagine the implication or the effect that it is causing, right? The sensitive data of millions of users is exposed, right? With some brute force techniques or maybe some sophisticated techniques. Yeah. So it's important, and I couldn't fit all the attacks that had happened in last 2 months. So imagine like what has been happening for this year, and we are still in the seventh month of the year, right? So just imagine how the year will end up. Okay. So yes, these things are very important, and as application developers, architects, security experts, QEs, we need to understand, right, where we are opening up these holes into the system, right, which the attackers are exploiting later on. Yeah. So to set up the context, let's look into a few of the security principles. Yeah. So which in my view are applicable at any level, whether you're starting designing a new system or you are working with an existing system and you are trying to improve it, or nowadays in agile and scrum world, right, where we release new features say every week or every fortnight, right, they are also these things very well fit in. So the first one is the principle of least privileges. So the idea of this one is that do we understand all the users that are accessing our system? So it could be the internal users or the external users of the system. Yeah. So it could be your application users, it could be your technical users, it could be your operations or support users, right? And do we understand that what are the accesses that these guys require, right? So say our operations guy will have very detailed privileges to the system, right? He can log into your server, he can check the logs, he can log into your database and all. But certainly your application users shouldn't have the same set of references. Yeah. And then based on these accesses, right, which each of these user requires, um, do we recommend to define certain roles, right? So we sort of give them certain names, which contains these finer accesses. Yeah. So now, once you have defined these accesses and roles, right, consider when this access is needed, right? Is it a time-bound activity that this person is using, right? And have some means of revoking these accesses once the activity is done. right? So say if a operations colleague is doing a deployment, right? So are these accesses required only during the deployment phase, or you will just leave this user to have the whole, say, system level, root level accesses throughout? Yeah. So that is important. Then try to understand like concepts like separation of privileges, right? Within the when we talk about application users, right? Are all the application users same? So I think there's a question someone raised. And oh, okay, okay. I understand that you are not able to read through the slides. Okay, so I have switched to the presentation mode. I hope that helps. Okay. Yeah, so we were at separation of privileges, right? And when we talk about application users, right? Do we understand what are different type of users? So you would have certain administrators accessing the system through your application, right? You will have normal users. So are the privileges separated for them, right? And then the whole idea of compartmentalization: are they able to access all the systems or a certain part of the systems? So all that has to be documented, has to be well thought through, and has to evolve as well as your system changes, right? Maybe during the initial days, you will spend too much time in sort of charting out all these things, right? But later on, it's important to continue with this and keep on refining this as well. Yeah. Now, the next one is principle of complete mitigation. So here it's important to understand that you allow the access of the system only through the secure channels, right? So it could be the partial, only some parts of the system, partial access, or the full access to the system. And when I talk about system, it actually incorporates all the system components, be it through application, be it through your servers, be it your databases, any part of the system. Yeah. So you have to properly set up the whole identification, authorization, and authentication mechanism. So user should be able to identify himself, right? Then we should be able to authenticate the user, right? He should be able to set up whatever identity he is saying, and then comes the authorization part. What our user is allowed to do in the system, right? So imagine you're logging into a system, right, to Facebook or any say social media site, right? So as a user identification process, you pass your say email ID, your username or mobile number, right? So that is the identification step. So system is able to identify you, that you exist in the system, but not able to authenticate you yet, right? Once you provide your password, then you are authenticated, and once you are authenticated, then only it is decided that within this system, what you are able to do. Yeah. Then access to all these protected resources, or rather through any of the protected parts of the system, should be monitored, right? It should be logged as to who is accessing that particular resource, and verified as well, right? Consistently, you do the audits and try to understand that there has been any suspicious activities, right? For these users, right? Then moving on to the principle of defense in depth. So the whole idea of this principle is that you set up multiple layers of defense, right? So here, the system should be prevented at multiple levels. Say not only at the external levels, but with the external levels, internal levels as well. Sorry. Yeah. So your applications should be protected. Your API layer should be protected. Your access to databases should be protected. Your access to physical resources should also be protected, right? And then you should be able to prevent or detect any breaches, right? And as and when any of the breaches happen, you should be able to react to those as well. Yeah. The next important principle is trust nothing. So, in my view, this is very, very much important. So, you have to understand what are the external parties, or maybe within the system, what are the components that you are dealing with. Whether you understand that what are the trust boundaries, as in what these parties are going to negotiate with you, what kind of data they are going to provide you, what format of data they are going to provide you, right? It is important to understand this very well, right? And then whenever you are talking to these parties, right, be it external parties or internal parties, you have to make sure that whatever data you are getting has to be validated, if required, sanitized, right? And the best approach here is to be whitelisted. Okay, so imagine a scenario where you enable a SaaS platform, right? You have created a software as a service, and many people are actually building applications on top of it, right? So all of these are actually trusted parties for us. We understand, right, that they are going to consume our APIs, and then they are going to create resources or instances and through our APIs, right? But we are not sure about the security implementations at these levels, right? And that is when we have to validate the input that we are getting from these sources. Yeah. So this, in my view, is the most important principle. Yeah. Uh, Okay, then moving on to the next set of principles. So one important principle here is economies of mechanism, right? So here we need to understand that our design should be as simple as possible, right? We as a developer have a itch, right, that we want to build more sophisticated systems, right? You want to implement complex algorithms and all, right? But understand that the simple systems are the most effective ones. They are easy to maintain, they are easy to inspect, and they are easy to fix as well, right? So while designing anything, don't try to create dependencies on you or on specific set of people who have special skills, right? It should be possible for anyone who is actually authorized to inspect or fix or maintain that particular system, right? And wherever possible, make sure that you reuse the well-defined or well-established solutions, right? When we are talking about security, especially, right? So use the secure frameworks, keep them updated rather than implementing them yourselves, right? Same applies for your cryptographic library or cryptographic function usage as well. Try to use whatever comes from your frameworks, right, rather than implementing it yourself. Yeah. The next one is that your system should have defaults which are fail-safe. Okay, so by default, the configuration should always be secure. Okay, so it shouldn't happen that if I'm say deploying an instance on AWS, right, and I have set up say a Ubuntu server, and I open up all the ports, right. That is not what we are trying to do here, right? So the default configuration should be secure. You should open up only the ports that are required, right? And then by default, maybe you only allow reads, right? So the best example is your file permissions on Unix, right? I mean, you have seen that by default it's always read, and you have to change the owner or change the permissions, and then only you will be able to update it, right? And wherever a protected operation is, right, the system should revert to a state where which is safe in terms of security, right? So your default should always be safe and should be minimal. Okay. Then talking about openness of design, this is quite related to economy of mechanism, right? So here the idea is that your design should be open, right? Follow the best, well-defined best practices, guidelines, right? Don't rely too much on secrecy, keeping things private and all, right? So certainly wherever needed, wherever we have confidential data, classified data, sensitive data, that has to be protected, right? And that has to be encrypted as well, as and when needed. But we should always aim, we should never aim for security through obscurity. Yeah. So just keeping just keep these principles in mind for the rest of the talk and for your future projects as well, right? So these are very well defined principles. Yeah. Then another perspective to this, right? So so far we were very risk averse, right? And let's look at certain risk-based security analysis, right? So this approach is very much relevant when, say, people are doing audits to your system, right? Or when you would be analyzing some other system, right? So this is mostly the approach that you take, right? And coincidentally, this is the approach that the hackers also take most of the times, right? So here the idea is that what attack surface you are exposing, right, to the external parties. So be it attackers, be it your auditors, right? So the whole idea is that do you understand all the interfaces, right? Any of the entry and the exit points to your system. So this could be anything. I have listed few examples below. Yeah, it could be your interfaces where you interact through your forms and fields, right? It could be the HTTP headers and cookies as well. So they are mostly the technical information, maybe not filled by the users, but attackers can easily manipulate these information if the right content policies are not set, right? Then same applies for APIs, then file uploads and downloads, right? Wherever you allow users to upload and download files, whether you restrict the size usage to prevent denial of service attacks, right? Or whether you prevent certain file attacks like zip bomb attack, right? Where say a small zip would contain another zip, would contain another zip, and so on recursively. And as you try to peel off this onion, right, to remove one layer after another, you will realize that this is actually a never-ending story, right? So whether you are protected, well protected against these file uploads, right? Then your entire set of persistences, wherever you are holding or storing data, be it your databases, caches, right, in-memory storage or client-side storage, right? Are your cookies well protected? Are your databases well protected? So, by the way, in the year 2019, most of the attacks were due to your misconfigured databases, and that too happening on the cloud providers. So, on AWS, GCP, Azure, people have left the default passwords on the databases, and that was cause of the most of the security breaches. Yeah. And then whether you are receiving or sending email or any other kind of messages, be it say your SOAP messages or messages through your message brokers or queuing technologies, right? Whether you take any runtime arguments or do you consume any open source dependencies. So if you see, your system is actually considering, or here in this framework, we are actually considering all the possible interaction points to the system, right? Whatever is entering to the system, whatever is leaving the system, right? And this actually, in the nutshell, is the attack surface that we are exposing, or the total risk that we are exposing from our system, right? So now the whole idea is we have to look into each of these layers one by one and provide the relevant or apply the relevant mechanisms or prevention techniques so that all of these are well covered. So probably I wouldn't have covered a few more, but this is the idea, right? So this is actually how auditor will also look at your system. So they will right away go into all the open source dependencies and try to see which are the open source dependencies that you are using. Are there any open source dependencies which already have known vulnerabilities which they can exploit? Yeah. Are you using very old open source dependencies, very old versions of them, which you say you have not patched for years and they are open for exploit? So this is just to give you an example how these people in different roles, right, be it black hat or be it white hat, approach your system. Yeah. So just a few examples of the web application attacks, right? So we talk about phishing attacks. I mean, we hear these terms very frequently. I've just kept this as a reference here so that we have a common ground, a common understanding on these, right? So phishing attacks, when the attackers pretend to be someone that you trust, right, and whom you will reveal the information. So they are actually disguising you to take certain action, right? And eventually you reveal the action. You perform the action whatever they want you to do. Yeah. Then one of the highest rated OWASP attack, that is the injection attack, right? So it comes in different forms. So here the idea is that your system components are attacked, right? To execute certain malicious code, yeah, and then try to steal information or do something which is not called for, yeah. Cross-site scripting attack also comes into various ways, but a way of approaching this is through an authenticated and authorized user, right? Where you to a user, you try to execute certain malicious code. We'll look into this a bit later on, right? Then comes the session hijacking, and related to it is the man in the middle attack, right? So here the idea is that you have unsecured sessions, right? The attackers are able to exploit it, right? And they are either able to steal the information or use the information that they have, the technical information that they have got, to impersonate the users and carry out certain actions on their behalf, right? So it could be your user details, your access tokens, your session IDs, and so on. Yeah, and we'll talk about this as well later on. And one of the important ones, zero-day attack, right? So here, as I mentioned in the last slide as well, right? So here the attackers try to exploit security flaws, right, on the libraries or the software components before they are patched, right? So you know that our software component is flawed, right? It has certain vulnerability, but people don't know how to patch it, or the patching is somehow delayed, right? And that gives them the time window to exploit this. Okay. Yeah. So now we move on to the OWASP top 10. So I'll highly recommend you all to go through this, right? Whenever you have free time. So this is sort of a I can say Bible for security. Yeah. So let's look at the landscape, right? So here we have top 10 attacks from the year 2010, 2013, and 2017. So these are the last three rollouts of OWASP Top 10. So the next one is expected in this year, 2020. Yeah. But if you see that most of the attacks, right, are still relevant there, right? And we are talking about almost 10 years into this time window, right? Starting from 2010. If you see, injection is always on the top, right? I mean, is it really so tough that we are not able to prevail these injection attacks, or is it just that we are overlooking it? But imagine the time frame over the last 10 years. This has been the most prevalent way of attacking the systems, and we still sort of tend to ignore this. A few other related ones, cross-site scripting and all. We'll look into all of these in more details. But the idea was just to make you aware of the things that we have been ignoring for years now. Yeah. Yes. So just a quick summary of these attacks before we go into more detail, or rather, we'll go into the details and then talk about them one by one. Yeah. So here I have just listed all the 10 attacks and just a brief discussion about them. But in the following slides, we have more details about them. So starting with the injection attack, right? The most common one. So here the idea is when the application sends or receives invalid or trusted data, right? So here the intent of the attacker is to run some malicious code, right, or make the system perform some unintended behavior, right, to maybe steal data from the system, or maybe to overload the system to the extent that it is not able to serve the legit users, right, or maybe to create damages in other forms. Yeah. So here the source from where this attack can be triggered can be many. Yeah. So your get your post parameters, your path info, right? This is especially relevant when you are doing certain file operations on the OS level based on the user inputs, right? When you don't secure or don't use the encrypted HTTP headers, right? When you allow systems to upload the files, and then the payloads, the request payloads that we have. Yeah. So all of these can actually lead to various injection attacks, right? Exploiting maybe one or more functions that come from that component which the attacker is targeting. Yeah. So the injection attacks could be at various levels, as we have been discussing, right? It could be at the SQL level, right, where so the user is able to manipulate the queries that are executed at the DB level. Yeah. So a variant of this is when you actually modify the behavior of your ORM, the object relational mapper component that you are using, right? Again, related to SQL. Then directory traversal is when based on the user input, you are actually doing certain directory OS level operation. Yeah. The next one is also sort of related when a user input or a user action actually triggers a OS command level step, right? The next, yeah, we discussed about ORM. The LDAP is more coming from the directories of the users that you maintain, right? And then you try to attack through that path, right? And then the expression language attack is where you try to manipulate the expression language that is defined in the system and try to inject certain malicious code or malicious scripts there. Yeah. So example of SQL query and how this can be attacked, right? So here, say, imagine if we are using the simple select queries in the system and where we have a condition on the customer ID variable, right? And this the ID, the value of this variable is actually passed through the user input, right? So I pass the user ID from the say the user inputs that directly, or we read it from the session token, and that is actually set against the customer ID, right? And here we are reading all the accounts where this customer ID is referred. So it would be very easy to refer this or to manipulate this if, say, I append a condition into the actual value, which always is actually true, right? And hence, this leads to reading all the customers because a part of the statement is actually true, and this was appended with a or condition. So this is most common example that you will see. But how to prevent these attacks is more important, right? And then in the references, you can actually find similar examples for all the other type of injection attacks. Yeah. So the prevention is that you always should be using the safe APIs, right? And that reduces the risk of your injections, right? As we said during our principles as well, that we have to validate and sanitize all the user input. Yeah. So it is important to understand what type of input a user is entering, whether he is supposed to enter a string or a numeric value, right, or a Boolean value. Wherever possible, give the input values for the user to choose from. Yeah. And if the user is entering, say, a email ID, whether you are validating that to be a right email ID or not, right? And then if the user is just entering the strings, make sure that he is not able to embed too many special characters or maybe escape them and still embed the special characters, right? You should not be able to embed any script tags and all, right? So it's very important to put this validation based on the type of data that the user is entering and to sanitize that data as well. So in the sanitization step, if say the user still enters any of the say script tags or non-allowed characters, that would be cleaned off. So it is very important, right? Then wherever possible, provide the users a whitelist of values to choose from, right? Rather than allowing them to enter the values on their own. Yeah. Avoid eval and exit functions as much as possible or to almost zero. Yeah. Whenever you're doing SQL operations, use prepared statements. Always don't use your select statements. Use insert statement, badge insert statements, upsert statements, right? So these are parameterized statements where they take the input from the user, but rest of the and this input is actually sort of validated at the runtime based on the type, and hence prevents from the uh, embedding any malicious tags there. Yeah. And then wherever possible, always use the limit and offsets when reading the data from your databases. So at least it will prevent the mass disclosure, right? So even if say a user is able to manipulate the system and he is able to uh, execute a query successfully, right? This should not be leading to basically reporting or making all the information available to him, right? So we should try to reduce the impact as much as possible. So I think there was a question, which one is important? Which measure is convenient? And so all of these measures are very much important, right? Based on which component of the system you are dealing with, right? So when I am communicating between, say, my client and the API layer, the first one is very important, right? The second one is very important. Third one is very important. When I'm communicating between, say, my API layer, my middleware to my database, maybe all the SQL related injection preventions are very much important. So all of them are very much applicable, right, at the different levels or different layers in your system, right? So and you have actually this whole injection prevention cheat sheet also available from OVA's site, right? So you should go through these and try to understand at which level, which layer you apply which of these. Yeah. Uh, then moving on to another important one, which is talking about the. Let me just arrange the windows here. Yeah, broken authentication and session management. Yeah. So here, the idea is that we have certain vulnerabilities exposed in our authentication and authorization flow, which the attackers are able to exploit, right? They could be able to exploit this manually or maybe through some automated attacks, through some brute force attacks and so on, right? To gain the control over a user account, right? And then related to this one is the session management, right? So once you have established a session, right, you should be able to protect that session information also very well, right? So your session IDs should be very well protected, right? They should be possibly rolled or rotated as much as possible. They should be always time bound and so on. Yeah. So some prevention techniques here. Yeah. So I think we all must be aware of all of these, right? But just to put things in perspective. So always define length for the password, right? The complexity, the character set that you allow. Make users to rotate or reset the passwords. Don't allow them to reuse the passwords that say they have used for last 3 times or so. Yeah. So prevent against setting up weak passwords, right? And make sure you check against say a few top K worst passwords, right? So few passwords are very much used where novice users just send them. So terms like password, right? Password uppercase, password lowercase. These should be strictly avoided. Yeah. Your passwords should always be secured, right? When stored, right? So the idea is never store passwords in plain text. Always encrypt the passwords, and along with the encryption, use a strong encryption algorithm. Always had a append a salt, use a salting while encrypting your
Sir,
passwords
you are
and so
not
on.
audible, sir.
Hello.
Yeah, now you are audible, sir.
Okay. So
Hello?
yeah, I'm audible now. Hello. Okay, okay. So I see people writing in chat that am I audible, so I'll proceed. Yeah. So so we are talking about securing the passwords, encrypting the password, and salting the passwords. That is very much important, right? Using the one-way hash function, right? So it shouldn't be able to the attacker should not be able to decrypt the passwords, right? As they even if they catch hold of them, right? So another important aspect is that you should always limit the failed authorization method. So don't let attackers to use the information and keep on trying, say, all the password combinations against a particular user account, right? So after, say, a fixed number of unsuccessful attempts, the account itself should be blocked, right? And you force user to reset the password. Yeah. So this prevents against the brute force or other automated attacks, and this is very effective approach actually. Yeah. Then wherever you have such mass authentication failures, right, these should be locked and right alert should also be raised. So if you know that your system is already under attack, right? Someone is trying brute force against your system, against, say, your user accounts. So this should be reported as early as possible. Yeah. Along with this, certain other mechanisms which are very important is you should have proper registration process, the recovery process, right? The API accesses should also be hardened as you set up the well-established OAuth time credentials flow, or other secured means like API signatures, right? When communicating to APIs, yeah. If possible, implement multi-factor authentication where the users actually supposed to give two levels of password, and then you set another level of input through their email or through their through SMSs on their mobile or some other means. Yeah. And then that makes your login process more secure, right? And most important of these is never deploy any default credentials at any level, be it for your users, be it for your system components like your databases or any of the infrastructure services that you consume, be it your operating systems and so on. Yeah. So if you take a glance over these prevention mechanisms, these things look very trivial, right? But once it comes to enforcing these things, probably we miss out leaving a loophole in the system, right? Which later can be exploited. Yeah. Okay. So moving on to the next topic, which is sensitive data exposure. Yeah. So here we talk about leaving the sensitive data with the vulnerabilities to be exploited, right? So here the idea is to protect the sensitive data like your passwords, credit card informations, maybe your social security numbers or PAN card numbers in our case, right? Credentials, any personal identifiable information, right? With the extra protection. And we talked a bit about this, that these should always be encrypted, right? And then right sorting mechanism should be used while encrypting or hashing these rather. Yeah. So here the idea is that the attackers usually easily exploit the transport level, the weaknesses in the transport level security that we have, right? Whenever we are passing this information insecurely, that is when you have not set up, say, HTTPS on your server, right? And all your communication is in plain text, right? It is not encrypted at all. Or even HTTPS is also susceptible to attack, which we'll see later on, right? Even when the data is not stored properly in the session cookies and all, right? So these are the places, or these are the attack surfaces that we leave open when we talk about the sensitive data and how attackers get catch hold of it. Yeah. So here, the classification of data is very important. You should know actually which data is sensitive or critical, confidential to your system. Yeah. So this could be based on your business needs. It could be based on the privacy laws of the countries where your users are, or various regulatory requirements as well, right? So data should be classified, and you should know about it. Yeah. And then make sure it's all encrypted with the strong algorithms. Uh, okay, so I'm sorry, I'm always referring to encryption here, but the correct term is hashing. So the data should be hashed. And whenever you have to read the data back, it should be encrypted. Yeah. And then you should ensure that the data is encrypted not only in the rest, right, when it is stored in the databases and all, but also during the transit, right, using the secure protocols, right, like transport level security, right. We should enable strict HTTP security by default, and we will see how to set it up later on, right. And then, wherever possible, disable caching of these responses because your data can get cached at various layers. It could be cached at CDNs or the any of the layers in between. So this should be prevented completely. Yeah. So this actually provides a good set of prevention list against losing out any of the sensitive data, right? Either at rest or during transit. Yeah. Uh, Moving on to the XML entities, external entities attack. So after say prevalence of JSON, right? XML attacks are actually have reduced a bit. I have personally not worked on XML at all, but I have just kept this because this is still in the OWASP top 10 list. Yeah. So here I think the idea is that the XML parsers are very susceptible to these attacks, right? Where you can easily provide a reference to an external entity, and when this external entity is invoked, right, you try to gain hold of sensitive data, yeah, or maybe perform some request forgery. So personally, I don't have any experience on this, but I have just kept this slide for reference. Yeah. So here are some prevention techniques. So I have never applied any of these. Yeah. Moving on to the broken access controls, right? So here, the idea is that the access controls that we set up, and this again goes back to the principles that we have set up while we started our talk, right? So it's very important to have the well-defined access control mechanism set up, right? So that we never leave any open vulnerabilities when talking about the system. Yeah. So we talk about certain things earlier as well, that the principle of least privileges should always be followed. If you remember, we talk about fail-safe defaults, right? Where the privileges by default should be kept to minimum, right? To perform the required actions based on whatever user profile you are targeting, right? And whatever this role is intended for, right? Then how often these access controls are required? Are they time bound? Right. All these things are also should be captured. Right. Then you should limit these access controls to various sections or compartments that we talked about earlier. Right. Then few things that has to be enabled on the server side, that you disable directory listing and all. Right. Which is sort of related to this. Yeah. And then monitoring and logging whenever you see a wide access control failures into the system, and should be alerted to the admins. Yeah. The next one would be on the API side, right? When you're talking about platforms or softwares as a service, right? So here, the whole interaction happens to the APIs, right? We don't know who our applications are, right? So here we apply things like rate limiting at the gateway level, right? So each set of API layer is actually exposed via application or API gateway, where these rate limiting policies can be set up based on different customers or different accounts, and these can further be used to prevent against these mass attacks. Yeah. Again, looks very common sense things, but we often tend to miss it out. So the next one is on the security misconfigurations, and I think we have touched upon this multiple times. When we leave the security configurations or vulnerabilities open for exploiting, right? Leaving your databases or say file systems or ports unattended or unprotected, right? Using unpatched or older dependencies and not updating them periodically. Yeah. Credentials with default authentication. Say you set up a database like MongoDB or MySQL or something, and you just continue with the default database forever, right? Or the other thing here could be that when you don't change your database or set of security credentials on different landscapes, right? So whatever you have in the development system continues to your staging or quality assurance system, and then continues to your production system as well, right? Then leaving any of the server ports open, right? So it's actually quite possible that we leave a lot of server port open, which can be later on used to exploits, right? Or even the required ports are exposed out of your gateway or firewall, right? So imagine where we have a three-tier application, right? And where your say middleware is interacting with a database, right? But you will never have any scenarios where external parties interacting directly with your database, right? So the communication between your middleware and database should always be limited within your network, right? It should be always behind your firewall or your gateway, right? And should not be made open anytime. Yeah. So AWS security groups actually allow you to implement this very nicely, right? Even if you have ports open on, say, OS level, right? They are not exposed externally, right? And anything else that should be secured and maybe not covered here. Yeah. Okay, so we talked about a lot of preventions as well when we were when I was sort of introducing this particular one thing. Yeah. So yeah, here we have covered pretty much everything. So we'll move on to the next slide. Cross-site scripting attacks. So this is again one of the most prominent attacks that have that is still consistently in the OS top 10 list for almost 10 years now, and I'm sure this will continue to be there in the list further as well, right? So here the important thing that we need to understand is that here we are leaving the system either through your client side interactions or server side interactions, right? To inject certain malicious code that can be executed. And again, this can happen on any layer. This can happen on your UI applications or through backend as well, right? And there are different forms of this. There is a reflected cross-site scripting. There is a persisted cross-site scripting, and there is a DOM-based cross-site scripting. These are the three prominent ones. So reflective is where you are able to. So sorry, I'm not able to collect it. I'll talk about it later, but let's go through the sequence now. So here, in this example, we are taking, say, request as an input, and then based on this, the user is able to modify the CC parameter, right, which the user is entering as a value to the credit card, right, and then this is actually exploited for a certain type of injection, right, through the client side injections. So prevention is that we talked about these earlier as well, that we should always escape the untrusted data that we are getting from the system. So this is also reflected and stored cross-site scripting vulnerabilities. We should always sanitize this input, right? So wherever possible, whatever body attribute or payload we are getting from the from the users, right? This should be sanitized to contain any of the script tag or any of the non concept context sensitive data. Yeah, and we should always set the right content security policies as to from which sources we are serving the content, right? And we'll talk about this later when we talk about the secure headers, right? So here the idea is that this prevents the vulnerabilities from any external sources which are actually not intended to be communicating with us. The next one is talking about insecure deserialization, right? So we talked about that we are going to transit this data, right? And this data could be your binary objects, could be your files and all, right? And then a deserialization process is actually getting this binary stream back into the desired target type, right? It would be a binary object, be it file. So this is very common when we have these Avro, protobuf kind of binary sort of communication layers between our system components, right? So though they are faster, they are very compressed, right? They are more exposed to these kind of attacks as well, right? So here, the data itself can be deserialized, and while deserialization, this can be modified, right? To include malicious code. And this code then gets maybe stored or maybe executed on your server, revealing the unexpected information. Yeah. So yes, so here we can always perform integrity checks whenever we are, say, encrypting or hashing something, right? This could be possible. Then the code that deserializes should always be run with the least privileges, right? then we should always log these deserialization exceptions wherever we are not able to perform the integrity checks properly or deserialize the results. And these deserialization should always be done in the sort of sandbox, right? So that it doesn't impact the whole system, right? Then, yes, the most important is when you see a mass activity leading to these deserialization issues, then you should always be raising alerts, automated alerts, right? So that's the operations guy or support guy can actually look into it. Uh, this we have discussed earlier as well. That is when using the components with known vulnerabilities. So, if say most of us would be quite familiar with Java and Python, right? So whenever we have a common functionality to achieve, right, we try to find out some open source library that is already implementing it, right? So, but as you go more towards productive usage of this, right, it's very important to understand where these components are coming from, what is the community support, if the vulnerabilities are identified in these components, how quickly they are patched, right? And as the vulnerabilities are patched, then you have to make sure that you also try to do the same. So I can tell you from my personal experience that we are doing a release every 3 weeks, right? And in these 3 weeks, every week, actually, we look at for these vulnerabilities. Actually, rather, this whole process is automated in our deployment pipelines, right? And is actually done automatically. So we already know, based on the common vulnerability databases, what are the new vulnerabilities getting reported against the components or the libraries that we are using, and we have to fix them, upgrade them, patch them as early as possible. Yeah. Uh, Yes, so that what comes in the prevention. So you should always have an inventory of the libraries or the components that you are using. Have standard mechanisms. If say you are using Node, use the npm package manager, right? If you are on Java, use Gradle, Maven, so that you keep track of the dependencies. I mean, quite often what we do is that we just include the jar files into our builds, right? And we just refer them directly. But that's not the right way. I mean, then you can't track the unsecure or unpatched dependencies or versions. Right? Then the CV or NVD databases are the ones which are open, and they maintain the vulnerabilities of various Apache components or open source components. So these can be checked periodically for any vulnerabilities and in the components that you are using. Yeah. So and then whenever there is a possibility, create security patches, apply them as quickly as possible, right? So that you are always up to date with respect to the component usage. Yeah. The next important one is insufficient logging and monitoring, and this we have always been talking about. That always certain sections should be logged, and if you see a mass activity or mass logs of a particular type, right, then there has to be a monitoring on that as well. Because see, the best possible thing is if someone is trying to steal something from you, right, and he gets unnoticed, right. So that is what attackers are also dreaming for, that they are able to perform the operation or the action that they want to do and they get unnoticed. So it's very important to have the right logging mechanisms and monitoring infrastructure in place, right? And this could be for the failed logins, for any invalid inputs, for any suspicious operations that you see, right? Which can further cause leakage of any sensitive information from your system or execution of any code or any action of any of these suspicious actions. Right? Yep. So we talked about these preventions as well for this one. Yeah. So next comes one another important aspect which is quite ignored here. So the things that we have talked earlier were more from the development perspective, right? As an application developer or architect, what all you should consider. This I would say is more from the operations or secure operations perspective, right? So when you have your predictive systems up and running, right? How do you ensure that they are communicating securely, right? So HTTP security headers are mostly the response headers. We set various of these headers to basically as a precautionary steps or defining the constraints for all the operations or the content references on the UI, on the applications that we are communicating. Yeah. So let's look at the content security policy header. So this is a very comprehensive header, and you should look into this in more detail. So what it defines is, and this actually protects you against multiple vulnerability types. That is very important to mention. So it protects you against cross-site scripting, pigjacking, frame injection, and so on. So here the idea is that this actually has lot of directives. So you can define what are the script sources that you allow to interact with. What are the font sources? What are the images, media sources, style sources, and so on. So imagine if you are building a UI application on React or Angular or any of the UI frameworks, right? So one possibility is that whatever dependencies you have, you actually include them as part of your source code, right? As additional dependencies. So in that case, probably you will say that, okay, I don't refer any of the script, say JavaScript from any of the external sources. But quite often what happens is that we are using these set of resources from, say, content delivery networks or from the source site itself, right? So in that case, you will specify the sources which you want to open up for communication here, right? And then the browser will make sure that any JavaScript is coming from only this set of resources that you have defined here. Same could be for the fonts as well. Same could be for the images. I mean, say if I'm putting all my images onto say a document storage or something, right? So I can define which domain this image source is coming from, whether it is self, which is the most restrictive, or you open up or you say like, okay, I'm uploading all my images on Flickr and I'll be going to read it from there, right? One important example here is like if you embed Google Analytics into your application, right? So then you have to open up certain script sources, right? Because here we embed the Google Analytics script and that runs as part of the code and captures the various actions that users are performing as coded by us. Yeah. So again, a very, very important header, response header that you should look into more detail. The next one is about strict transport security. So I'm sure all of us know about HTTPS and HTTP, right? And the differences between them. So when we move upgrade our sessions to HTTPS, right? We are actually encrypting all the payloads or all the headers and all that we are passing for this communication, right? So using our strict transport security, right? So here the idea is that we should be able to communicate as much as on HTTPS, right? But there is one flaw that will go to next. But from the backend side, we should ensure that we have a valid domain certificate, right? The HTTPS or the TLS certificate that we specify, right? And this should apply on all the subdomains as well, right? And then we set our max age for this as well, which is typically 1 year. And yes, so this is by default that how you deploy a HTTPS certificate and you say like, okay, my site or application is secure now. But there are certain improvements that can be done on this. So a secure state HTTPS is actually based on trust of first use. Okay, so what happens is if the first HTTP request is made from the browser, right? Then this would be then elevated to HTTPS version of it. This. So there is a redirect which says, okay, that all the resources on this host are actually served on HTTPS. And then going forward, the browser will make all the calls to HTTPS. So this first step itself is again susceptible to the attacks, right? Because in the first attempt itself, we are actually making a HTTP call, which is not encrypted. So the communication here is not encrypted at all. Yeah. So here the idea is that we can define a HSTS preload as well. Okay. So if we meet all the criteria that we, sorry, I jumped few slides. Yeah. If you see all the criteria that we have met here is right, then we actually qualify to be into the preload list of the browser. Okay, so browsers actually maintain a version of the sites or the domains which are ensuring strict HTTP, right? And this is actually updated with each browser release. Okay, so here you have to understand that once you enable this, it could take up to a month for maybe the next browser release, and that is when your domain will get reflected. Yeah. So here the browser automatically knows like, okay, this protocol is on strict HTTPS, and it will never make the first plain HTTP call to your domain. It will always be HTTPS. Yeah. And another related improvement here is to have the HTTP public key pinning header as well set. Yeah. So here the idea is, so this protects you against forging of the TLS certificates itself. So the HTTPS certificate that we generally put, like, so there were a few cases when these certificates were forged. So in this case, what we do is we send, and this HTTPS certificate is actually the public key that we are exposing out, right? And that the server is exposing out, right? And the browser is just ensuring that this is signed properly, and then the signing authority is correct, and so on. So what we do is that we submit the private key also, rather the hash of the certificate to the browser, right? Similar to the preload list, the browser also maintains this hash against our domain. Yeah. And this typically is updated once in a year. So we have to be careful while setting it up. So now what the browser does is whenever it makes, say, a HTTP or HTTPS call, right? So it will check the hash that you have already provided against your domain, right? With each and every call where this response header is set. Okay. So with every response, we will embed this particular hash, and browser will already check against the value that we have submitted, right? So this provides you an additional layer of protection or improvement of our HSTS. Yeah. Then the one again cross-site scripting protection, right? So here you should be able to specify, right, against the site from loading the content or defining from which sources the scripts are allowed to load. And this is actually our old header, and now the content security policy sort of has replaced this one. So, but this you need still if you expect your users to be using old browsers. Yeah. So, or old versions of browsers. I mean, say if they are still on IE and say older versions of Chrome and Firefox, then you actually set it up. Yeah? The extreme options header is actually quite useful one, where it prevents your the UI or web application to be embedded inside the iframe. Okay, so what typically can happen in UI redressing attack is that the attacker could take your site or take your web application and embed it inside a iframe inside another domain and serve it on a different domain, right? So the idea is that they are clickjacking the user inputs that the users are making, right? They are tracking the keystrokes or the actions that users are doing, and then again the same can be used further for making any attacks against the system, right? So here, the options that this directive provides is whether you deny it completely, that your application can't be embedded in any iframe, you allow it only in the same origin, or you allow it from the specific URLs, right? So wherever you have this concept of iframes, probably this header is quite useful. Yeah. X content type is again a mine type sniffing attack. So here, what happens is that when we don't provide the content type, right, the browsers try to act a bit smart, and based on the file extensions, right, they try to guess the mine type, right, or sniff the mine type in the technical terms, right. So here the idea is that we want to prevent browsers to make any decision, right? If the content type is not provided, they should not be acting smartly or trying to sniff the types on their own. So by setting the value to no sniff, you are actually preventing the browsers to interpret the types. Yeah. The next one is for the X download options, right? So quite often we download files, right? PDF files or Word files from the Word files from the servers, right? So here and we are always presented with a pop-up, right? Where the option is that you want to open it with the default application on your system, then it will open that file with a PDF viewer directly, right? Or you sort of download it, right? So here the idea is that if you want to prevent, say, users to open up the content, right? You actually set this header, right? You set it to no open, and then you would be only presented with a download option. You download the content and then process it later on. Yeah, again another useful header. So these are actually just a few of the headers. There are a few other ones as well. So there are some automated tools as well. So where you can define your URLs and they check for what are the security response headers that you are setting up, right? And what values do they have? Yeah. So these tools are actually quite handy. Yeah. So this, in my view, is also quite ignored topic and should be considered. Yeah. So now another section on. Let me do a quick time check. Okay, we still have 15 minutes. Yeah. So the next one is how to put these things in practice, right? We have talked about a lot of things during last 1 hour or so, right? So now where they fit in into your complete development and operations part, right? So let's start with this infinity loop, right? So here we are starting this cycle from this plan phase, right? Where we said that we will have our security architecture defined, right? We do the risk assessment as to for the components which need more security concerns, right? This should be already documented and should be sort of addressed, right? And then during the design phase, you can actually do a threat modeling exercise as well, where you understand the attack service based on the different ingress and outgress things that you have in the system, right? Various components that you have in the system, and you already prepare for the measures or the preventions based on this. Yeah. So then you move into the coding stage. So this is where the developers are actually quite busy, right? So they are churning out code. And the important aspects here is that along with the code, you should have your automated test suites as well, so that your tests are also reproducible and can be executed as frequently as possible, right? Then you have the code scan measures in place. You have code reviews as well. So it's always useful to have it eyeballed by a PM, right? Then goes the build step, right? So you should always have automated build pipelines, which possibly could be doing your vulnerability scans, right? So here you basically see a list of all dependencies. You match the dependencies against the vulnerability databases to see if they have any unpatched vulnerabilities which should be addressed and so on. And if in case they are, whether you are able to release or maybe move ahead with those vulnerabilities or not, right? Then there are a lot of static analysis tools which can be actually used in the coding stage also, but they are always recommended to be in the build stage for sure, right? So they perform the static code analysis. So these could be your simple linting tools, your Sonar, and so on. Yeah, Sonar, PMD, find bugs, and so on, right? And when we talk about the Java world, right? And then there could be dynamic analysis tools as well, which actually work against a deployment and try to do some dynamic analysis of the source code. Yeah. Uh, so when your builds are ready, you actually deploy them and make them available for testing, right? So here, holistic security testing should be done. Penetration testing should also be done as and when applicable, right? Security testing should cover a lot of aspects, your authorization aspects, your interactions, right? The attack surfaces, trying to break the system, pass the invalid values, try to inject the script tags, and also this is where the QEs actually where the smart hacks and try to break the functionality, right? Then you are ready for releasing this, right? Once your QEs actually gives you a thumbs up. So at this point, it's important that you perform security reviews. So this could be your external reviewers or maybe specific security experts or dedicated security team and so on, right? Where they just go through all the processes that you have defined and they may try to reproduce certain steps on their own. Yeah. Once the feature or system is ready for the release, you deploy it, right? So here the recommendation is that the deployment pipeline should always be automated. There should be no manual steps, right? And you should have staged deployments. It shouldn't happen that from the development system we always move stuff to the production system, and so we should have dedicated systems for QEs to test, right? So these are important from traceability perspective as well, right? And as we talk about these stages, we have to make sure that these stages are also configured securely. As to right credentials, different set of credentials are used, different set of certificates are used, and so on. Yeah. And then we move on to the operations part of it, right? So once say your code is deployed, it is running there for 3 months, 6 months, and so on. So you should ensure that assessment of the deployed functionality or deployed components can be done periodically. Yeah, the configurations are always secure and always in place, right? And you set up certain secure operations principles as well as to who can assess the system, which parts of the systems he can touch, right? And whether these actions are logged or not, what kind of privileges they have, and what things they can do on the system, right? The next one is again continuous monitoring of the system, where you are still looking at the vulnerabilities that are they are against the deployed components, right? And you make sure that they can be patched or upgraded or so on, right? And then you do a threat assessment as well. So on your productive instances, if you see that there are certain attacks, there are certain threats, right? We always make sure that they are sort of addressed and can be acted on at the earliest possible instance. So this is sort of a continuous loop, and you can imagine this loop in a waterfall model or more in an agile model, where say you are releasing a feature every 2 weeks, and all these steps have to be reproducible and then maybe automated to the most of the extent. Yeah. So with this, actually, I'm done with all the parts. So if we have any questions, we can take it up.
So any questions from the participants?
So no questions means everything is clear or nothing is clear.
So, sirs, they have posted in the chat box how many techniques
Ah,
are
yeah,
available.
yes.
Yeah,
So you can,
you can just
yeah,
yeah.
feel free to post your questions in the chat box, and I'll take them one by one. So SQL injection techniques which are available, and but still it's a big issue in development area. Yes, you are right. So people still don't understand the whole nuances of injections, and at various levels the injections you can do. Not only SQL, I mean there are various other SQL injections also possible. So there is a SQL injection, or rather a comprehensive injection cheat sheet also available on the OWASP website, right? So I'll post a link in the references, and you can have a look later on. That talks about the injections, the techniques based on the frameworks that you are using, right, and how to apply them. So in PHP, the things could be different. In Java, in Python, they could be different. In Node, they could be different. And then it is based on the database or ORM that you are using. So this is all very well documented. Yeah. And then the next question is, what is difference between decentralized and distributed? Mm, okay. So in my view, actually, both of them refer to the same. Yeah, I may be incorrect here. Because when I'm talking about the distributed system, we are talking more about the cloud native microservices development, where we have different microservices, right? Each holding a part of your domain model or domain entities, right? And They are responsible for maintaining life cycle of those particular set of entities. So the idea is that the monolith is broken based on the domains or concerns. I mean, we practice the domain-driven design approach, right? And that's how we break up and come into a distributed system, right? Then these distributed systems can have their own persistences. They can have shared persistencies. Then these persistences can be implemented in multi-tenancy in different way. So that is a whole microservices-based distributed system that I have been referring throughout. Yeah. So how to perform DNS cache poisoning? Okay, so I have personally never done that, but I think okay, I'll put a reference from the OWASP site. So I would say for all your related questions, right? OWASP is the best source, and I think if I have to recommend one source, that would be the OWASP site. So you will find all the information how to carry out these attacks, what are the tools that you can use, and so on for preventing them, the cheat sheets and all. So everything is very fairly documented there. Yeah. So you can always refer that. What is the standard of DevOps for building reliable and secure systems, including application build, packaging, and deployment? So I'm not sure what standard of DevOps we are talking about, right? I mean, if you're talking about tools, and also there are tools like Jenkins or AWS Code Deploy and all, right? Which are actually based on fairly established guidelines and principles, and they always keep on evolving, right? So they actually take care of different phases that we are talking about here. That is, you prepare your builds. During the builds, what all steps should be executed, which static scan tools are enabled, which dynamic scan tools are enabled, right? And an option of enabling your custom tools, custom scripts for testing, running your automated tests, and so on. Yeah, and then packaging these artifacts, deploying them to our artifact store, signing them. I mean, if you have heard about jar signing and all, right? And then deploying them through various stages, running automated tests against these. So there are very standard, I would say, set of tooling available in any of the cloud providers that we are using, be it AWS, be it Azure, be it GCP, and they are quite flexible as well. Yeah. I have heard about their code is used to find vulnerabilities. Yes, on which language? Then? On their code. Yes. So Code is actually a commercial tool. I'm not sure whether if they have any open source variant of this as well, but right, they are useful for accessing vulnerabilities, and I think to some extent doing the scans, the static analysis as well. Yeah. Um which languages? I'm sure they support Java, Python, and Node for sure, and Ruby as well. Yeah. So in SAP, we have a different set of tooling that we use. Yeah. Standard specify here practices for groups including. Okay, I'm not able to get this question. So standard specify here practices for groups including development operations. Maybe if you can elaborate it, I'll be able to take it up. The next question is what tools you are saying for vulnerability scanning and for static and dynamic analysis. Okay, so the website actually gives you a list of comprehensive tools, but here in SAP we use Fortify, which is a HP tool. Yeah, so that we use for both static and dynamic code scans. Along with the Fortify, we use SonarQube as well. So SonarQube is again an enterprise grade static code analysis tool, which is actually quite useful. And when you talk about open source tools, you have PMDs and Findbugs of the world, which do the static analysis on your code. And they are very easy to configure. Right? So in your Maven POM files, you can easily put a stage and make it work against your code during the build stages. Okay, so can you please post the name of website? Okay, so in Google, if you search for OWASP, and you will find the link in the references also, which I'll share. Then you'll be able to find uh, almost everything related to application security, right? So we have only talked about the application security from the backend perspective. So they have new guides for your API security, Docker or container-based security, mobile application security, and so on. And they have been defining these top 10 vulnerabilities for each of them. Yeah. So it's very exhaustive. I mean, you can spend years and years reading through it. Yeah. How to manage secure software development. Okay, so this I would say is more of a organizational thing, right? Like I mean, I'm sure every big organization actually has a secure software development process, right? And which they follow across their different product lines, right? The same we have in SAP, and I think same is there in any company, be it Google, Microsoft, or anything, which actually comprises this whole infinity loop and all the steps that we have talked about, right? So if you see that whatever I'm presenting right now is actually a secure software development life cycle, right? Which covers all the aspects that when you are planning for a feature, right? What all things you should consider when you are coding it, when you build it, when you test it, when you release it, when you deploy it, when it is running live on your servers, right? So it talks about all the phases in life cycle, and you can get details about each one of these stages in OWASP and other sources. Yeah. Okay, so I don't have any of the tools ready on my system, so I can't demo in this session actually, and I didn't prepare for any of the tools as well, right? Because it takes time to explain, and it wasn't possible to cover any of these in this session.
So I think participants are done. Thanks a lot.
Sure.
It was very informative session, and even the participants have enjoyed your session. Thank you so much. Thank you. They're
I
asking for your email ID.